using action-level metrics to report the performance of multi-step keyboards. Multi-step text entry methods are used on mobile devices as alternative input methods for accessibility. These methods require performing multiple actions simultaneously, or in a specific sequence to produce input, known as chorded and constructive method, respectively. Text entry methods for languages that have a large alphabet or a complex writing system also use constructive or chorded techniques. The conventional error rate metric cannot capture important action-level information in multi-step methods, while the proposed unit error rate can. Consider entering the word quickly using a Morse code, which is a constructive keyboard. Both attempts with same conventional error rate as 14.28% due to an error in the letter L. In contrast, our proposed unit error rate reflects the state of the action-level errors and gives a better measure, 7.14% for the first case and 3.57% for the second. The action-level metric shows that learning has occurred with a minor improvement in unit error rate, but this phenomenon is omitted in the error rate metric, which is the same for both attempts. Unit error rate represents the average number of errors committed by the user when entering one input unit, such as a character or a symbol. Unit accuracy is the opposite and simply a convenient reframing of unit error rate. Instead of error rate, unit accuracy represents the accuracy rate of a unit. Apart from speed and accuracy, we also propose an input unit's complexity that categorizes each action in a unit, such as a letter or a symbol, into different difficulty levels, represented by the continuous values from 0 to 1. We conducted a user study to validate the new metrics. In the study, participants were divided into two groups. One started with the constructive method and the other started with the chorded method. This order was switched on each subsequent session. For the constructive method, error rate dropped from 9.54% in session 1 to 3.37% in session 5. For the chorded method, error rate dropped from 3.42% in session 1 to 2.16% in session 5. For the constructive method, unit error rate decreased from 2.04 in session 1 to 0.96 in session 5. For the chorded method, unit error rate started from 0.98 in session 1 and ended with 1.03 in session 5. We identified the letters that were both difficult to enter and learn to input accurately, the not learnt letters, and the letters that were difficult to enter but relatively easier to learn to input accurately, the learnt letters. The results demonstrate a high inconsistency in unit accuracy across the not learnt letters. However, for the learnt group, there is a prominent upward trend, showing that participants were learning these letters even in the last session. This figure illustrates the top 4 not learnt and learnt letters for the constructive method, highlighted in red and green, respectively. A correlation was identified between unit error rate and the time spent to enter the sequence of these letters. This suggests that these letters require higher cognitive and motor effort to enter. The figures illustrate not learnt and learnt letters for the Señorita chorded keyboard. Trends for all learnt letters were increasing, suggesting the occurrence of learning across the techniques. This figure illustrates the top 4 not learnt and learnt letters for the chorded method, highlighted in red and green, respectively. As one can see, the chords required more time than taps. These results demonstrate how the proposed metrics provide a deeper understanding of action-level error behaviors, particularly the difficulties in performing and learning the sequences and chords of the letters, facilitating the design of faster and more accurate multi-step keyboards.